All right, so in class you learned about soluble versus insoluble salts. Now, for something to be a salt, that requires it to be ionic, right? You have your cations and you have your anions, whether they be polyatomic, monatomic, whatever. But you have some combination of pluses and minuses. Here's some examples here. You have lithium phosphate, magnesium nitrate. The idea is that not all of these salts are soluble. Things like NaCl, KCl, NaOH, very, very soluble, as we know. But there's a lot of other ones like lead chloride and silver chloride, which are not very soluble. So the idea is to figure out which reaction between more than one of these salts will create an insoluble product. That insoluble product is called a precipitate, which is why you call it a precipitation reaction. Maybe you heard that term during lecture. So I want to show you an example of a reaction. Here's one right here. So you have, it's balanced. You see the coefficients, but let's say after you balance it, you have lithium phosphate plus magnesium nitrate yields magnesium phosphate and lithium nitrate. Think about what's happening here. So in the molecular basis, you have two soluble aqueous salts, lithium phosphate and magnesium nitrate. How do I know they're soluble? The answer is the solubility rules list. So this list is going to be your guide for this lab. You're going to use this to see which combinations of cations and anions are both soluble and insoluble. And everywhere you look, there's different versions of this list. Like, I don't even like number one. Most nitrates are soluble. All nitrates are soluble. Also, all acetates are soluble. That's C2H3O2 minus. All of those are soluble too. So this table, a lot of them are incomplete. And then you can just follow along for the rest of them. A common ion, or three common ions that keep coming up in terms of ones that are frequently insoluble, are silver, lead, and mercury. They're not soluble with much. So you can see that most chloride, bromides, and iodides are soluble except for these three. Also, most sulfates are soluble except for, again, those well, not all three, but those two. You have lead and mercury. I think also silver sulfate is not very soluble either. Yeah, I don't like this list, but this list will be good enough for the lab. And if this is the list that your professor provided in lecture, that's the one you're going to use. But there are more comprehensive ones out there. But anyway, let's get back to the reaction. If you look at this reaction, what's happening when you're basically pouring these solid salts into the water is initially they're both soluble. You have a lithium salt and a magnesium nitrate, very soluble. So once you do that, the lithium and the phosphate and the magnesium and the nitrate all separate from their ionic salt. The reason why is because they're soluble. And remember what happens when things are soluble. The positive and negative charges from the water molecules actually rip apart the solid salt to make them dissolve. So then you have your pluses and your minuses all free in solution. And in every one of these precipitation reactions, you're going to have 4 ions. That's why when you look at the worksheet, you see, for the example, it shows you reaction 1, you have 4 ions in the mixture. Ions in mixture is going to be always 4. Right? For number 2, it would be your silver plus, your NO3 minus, your Na plus, and your Cl minus. So there's always going to be 4 ions. And your job is to figure out which combinations, or well, it would only be one or none, which combination of those 4 ions will create an insoluble salt. Because what's happening is, when you have all 4 of them that are free in the water, remember this is an aqueous solution in water, they're going to move around and go really, really fast all over the water mixture. It's a mixture of them until the right combination of them hits together. Once the insoluble combination hits together, they're going to stay together and they're going to be insoluble. And that's going to cause a precipitate, meaning a solid to form. So if you were, I wish we were in the lab to do these, because if we were in the lab, we would see that once you mix lithium phosphate and magnesium nitrate, you'll see some cloudy precipitate start to form immediately. And this cloudy precipitate is magnesium phosphate. Because if you look at down here, magnesium phosphate, let me guess, it's not on the list. Yeah, this list sucks. Oh, here we go. Wait, most sulfides, carbonates, and phosphates are not soluble. Here, yeah. So most of the phosphates are not soluble, except for those containing the cations in Rule 2. So that's like the Group 1A cations. So magnesium phosphate is considered to be not soluble then, based on those rules. So that means it would form the solid. And then whatever you have left, which would be lithium and nitrate, you can write that they're together. But in reality, they're actually just going to be free, bumping around into each other in the solution, just like they normally would be. So then they're not going to bond together. They're just going to be floating around. Okay, are there any questions on that? Okay, so in terms of what we do with this reaction, the first thing is, like I said, to write the form of which everything is molecularly dispersed in solution, meaning how is the mixture represented? So that's basically every ion splits apart except for the combination that becomes a solid. That is called the complete ionic equation. So that's the purpose of it. I'm sure maybe you definitely learned how to do it, but the purpose of it is to show in the water, if you were the size of a water molecule, what would you see? And the answer for this reaction that we saw is you would see 6 lithiums, lithium plus ions bumping around for every 2 phosphates, for every 3 magnesiums, for every 6 nitrates. And you would see that reaction would cause the formation of solid crystals of magnesium phosphate, and those 6 lithiums will keep bouncing around with the 6 nitrates, and they're not bonding to each other because they're all soluble. So that's the purpose of the complete ionic equation, is to write the representation of the mixture in the water in terms of its ions. It's aqueous versus not aqueous, or sorry, it's soluble versus insoluble ions. Okay, so this, you notice how lithium is 6 here, right? The coefficients, they're from the summation of the coefficients, or the number of atoms of each element. So lithium here, there's 2 times 3. That's where we get the 6. And each lithium is positive. So you write 6 Li+. It's very easy to mess up the complete ionic equation. There's a lot of little tiny details. There's the coefficients. There's the charge. That's about it. But there's the coefficients and the charge. And you got to add all them up. Something like PO4 is -3. Since the coefficient of 2 is in the beginning, it would be 2 PO4 3-. Then for something like MgNO3 this is where it gets a little complicated, and I see a consistent error that every student makes at least once. Is for magnesium, it's pretty straightforward. You write 3 Mg2+ right here. But for nitrate, you see that there's 2 over here. I see so many times when we learn this for the first time, somebody writes 3 NO3 in parentheses 2. That's not right. It would have to be 6 of them. The reason why is because NO3 on its own is nothing. The reason why it's NO3 is because magnesium requires, because of its 2+ charge, requires 2 nitrate -1 ions to bond to it. So NO3 as itself is not a thing. You can't have 2 NO3s bound to each other. That's not stable. So that represents the number of ions that are just in the solution. So there's 2 of them in this compound. Then there's 3 in the coefficient. 3 times 2, when they're free, is going to be 6. So 6 nitrates. And then your job for the products is to find the combination that is insoluble based on the rules. So you can see that, okay, lithium is definitely soluble because, look, most salts containing the alkali metals are soluble. Not most, it's all. So lithium, it's soluble with everything. Nitrate, most nitrates are soluble. Like I said before, all nitrates are soluble. So nitrate is going to be soluble with everything. That automatically cancels out lithium and nitrate as being the precipitation ions. Therefore, by that process of elimination and reading the rest of the rules, you can see that magnesium and phosphate are the only ones left that will form a solid. Does that make sense? And you write that together as a solid, and everything else stays the same.
Yeah, we basically figure out the solids by the rules, and then everything else we write out as ions.
Exactly. That's it. And then those ions that are not touched, are not part of the product, are called our spectator ions because they don't directly participate in the formation of the precipitate. That's tough to say, but I said it right, so that's good. Participate in the precipitate. They don't do that. And then what you can do from this complete ionic equation, which is going to be your goal for each one of these, or for each one of the reaction 1, 2, 3, really for all of them. So all these reactions up here, you're going to have to write the net ionic, complete ionic, spectator ions, and the name of each product. So you need to get used to that. This is a very good practice for lecture also. So what you need to do at the end is you're going to cancel out, just like an algebraic expression, all of the common ions on the left and the right side. So if you're looking at this complete ionic equation, on the left side, you have 6 lithiums. On the right, you also have 6 lithiums, and you have 6 nitrates. Those will all cancel out. Remaining would be your 2 phosphates plus your 3 magnesiums equal magnesium phosphate. And be sure this... Oh, sorry. Yes, question.
You're just asking, you're just trying to see what changes.
You want to see what becomes a solid. So what combination of the 4 ions is insoluble? One more thing I want to add is, let's say no combination of them makes an insoluble compound. Then that's possible too. That means there's just no reaction that occurs. So that actually happens. Let's say you have lithium nitrate mixed with sodium hydroxide, right? Sodium hydroxide, based on the rules, it has sodium in it, very soluble. Lithium nitrate, based on the rules, nitrates are soluble and lithium is very soluble. It's going to be very soluble. If you flip them and mix them around, you'd end up with lithium hydroxide and sodium nitrate. Both of those are also very soluble. So the net ionic equation is just going to be the same ions on the left, same ions on the right. They all end up canceling out. No net reaction. So if you encounter one of those, don't think it's wrong, but it's possible.